So far, we've only been looking at monohybrid Punnett squares, or Punnett squares involving just one trait. At times, we want to look at the inheritance of more than one trait at a time. So if we want to look at the inheritance of two traits, then we can perform what's called a dihybrid cross. The prefix di means two, so we're looking at two traits at one time. A larger Punnett square is needed for a dihybrid cross. You can see there are 16 boxes instead of 4, and we have more places to fill in for our parents than before because we have more possible pairings of the alleles. Since we'll be looking at two traits at a time, we're going to need two different letters, one letter per trait. We'll still use a capital and lowercase for the dominant and recessive of each of those traits. So we'll do an example to show you how to set it up, and then do some practice on your own and check your answers. So we'll be working with the Punnett square packet that I provided on Canvas. You can either print that packet or you can simply draw the Punnett squares on your own on paper. It won't matter either way. So when we have a dihybrid Punnett square, we're going to have two traits. So notice that in this Punnett square, or this example, we have hair color as well as eye color. So I'm going to use my introduction here to record my key. My key will consist of two traits instead of one, and therefore two letters instead of one. So black hair is dominant, and blonde hair is recessive. So I'm going to start with my key. So capital B is dominant for black hair, and lowercase b is recessive for blonde hair. Eye color, brown hair eyes are dominant, so my second trait is eye color. And blue eyes are recessive. So when we have two traits and a dihybrid cross, we have to track both traits and the inheritance of both of them at the same time. To do this, we need to kind of keep track of both traits and also make sure we keep the order consistent. So whichever trait is first, which would be the trait that is mentioned first, that would be considered trait 1, and the trait that is mentioned second, that will be considered trait 2. So trait 1 is hair color, trait 2 is eye color. We want to make sure that we keep trait 1 first the whole time and trait 2 second the whole time. So if we look at problem number 1, it's going to be based on this question here. So what percent of the offspring could be expected to have both blonde hair and blue eyes? That's both traits at the same time. So blonde hair and blue eyes. So we're going to perform this cross that's designated by number 1 and described here in order to answer the question of that probability. So we're going to perform number 1. In number 1, Dad has black hair and he's heterozygous for that trait, and brown eyes, heterozygous for that trait. So both traits are represented. Mom, on the other hand, has blonde hair and blue eyes. So she, as you can see, is recessive for both traits, and both traits are accounted for. In this problem, you're actually given the genotype, so big E, little b, and big E, little e for Dad, little b, and little e for Mom. So to set up this Punnett square, we have to record all of the possible pairings of trait 1 and trait 2. So we need a B represented for hair color and an E represented for eye color. So we have our first B and our first E. So we're pretty much distributing kind of like the FOIL method. We pair our first B with our second E. So we also have a big B and a little e. We're going to pair our second B with our first E and our second B with our second E. I recommend writing this little key with the arrows to help you remember how to distribute each time. You'll notice that this has been started for you in the Punnett square. So our first B-E combination is recorded already, and our second one is also recorded. So we're going to fill in the rest of them. Notice in each case, the hair color and the eye color is represented, but also trait 1 is kept first and trait 2 is kept second. So notice that hair color is represented first and eye color is represented second, even though it looks a little bit strange to us because we're used to having the capital letter first. Now Mom, on the other hand, we're going to do the same thing, all the possible combinations of the B's and the E's, but you'll notice for Mom that all of her alleles are the same for her genotypes, so all of her possible combinations are going to be the same. So our second B with our first E, and our second B with our second E. Mom can only pass down the recessive allele for hair color and the recessive allele for eye color. Now we're going to fill in the offspring for the Punnett square, or the F1 generation. Remember, we're using two traits. Therefore, we need to have two genotypes recorded for each box. So we're going to pair our B's together first, that's trait 1, and then our E's together. Be very careful not to put BE, BE. You want a genotype for hair color and a genotype for eye color side by side. So again, we're going to record our B's and our E's. We're going to bring down the B from the top and the B from the side. and the E from the top and the E from the side. You'll notice that our genotypes in this row, this column here, are all the same because mom's allele pairs are all the same. As we continue, we see we have a different combination here now. Okay, so I'm bringing together my B's and bringing together my E's. And finally, our last column, homozygous recessive for everything. Now that our dihybrid Punnett square is finished, we can assess this and determine the probability of inheriting both traits at the same time. So maybe you want to figure out the probability of both traits being heterozygous in the offspring. So in this case, that would be these 4, which would be 4 out of the 16, or 1/4, or 25%. But remember, the question that we are being asked is up top here. What is the probability of the offspring having blonde hair and blue eyes? So we need to look for the allele combination that would give us blonde hair and blue eyes. So for blonde hair, we need to be homozygous recessive, and blue eyes, it needs to be homozygous recessive again. So if we look at our Punnett square, this is homozygous for both, recessive, homozygous recessive for both, homozygous recessive for both, and finally homozygous recessive for both. None of these others are homozygous recessive for both. So that would be 4 out of 16. We can reduce that, and then we can come up with our probability in percent form. Probability can be percent form, or it could be fraction form. They're specifically asking for percent form here. Why don't we try number 2? I'm going to pause the video and set mine up. You should do the same. Okay, so hopefully you've paused the video and you tried number 2 to set it up on your own. And let's see if we can check our answers. So for number 2, both parents are heterozygous for both traits. So notice dad here is heterozygous for the first trait and heterozygous for the second trait. It says both parents are heterozygous, so mom has the same thing. She's heterozygous for trait 1 and heterozygous for trait 2. Now remember, we're going to distribute the first B with the first E to figure out our pairings, the first B with the second E. Second B, first E, second B, second E. So our Punnett square should be set up like this. So here's our pairings for dad. So first B, first E, first B, second E, second B, first E, second B, second E, our distribution like this. Mom has the same. So down the left-hand side, we have mom's genotype, allele combinations. So if we perform our cross, remember we're going to record the alleles that pair. So 2 B's and then 2 E's. Notice that our combinations vary now because mom has varying allele combinations, unlike number 1. So if we continue to check our answers, here's what we should have. And now the probability is the same question as we had before. So we're looking for blonde hair and blue eyes again. The only place we see that if we scan all of our offspring is this bottom corner. So that's only 1 out of our 16, and that gives us a 6.25% chance. Take 1 divided by 16, and then we have 6.25% probability. Now the bottom here is our phenotypic ratio. It's a little more complicated because we're looking at both traits at the same time. So notice we have hair color and eye color. We need to count how many of the offspring in number 2 here have black hair and brown eyes. Notice dominant and dominant. Our second number is going to represent dominant for the first trait, so black hair, but recessive for the second trait, which is blue eyes. Our third number is going to be recessive for the first trait and dominant for the second trait. And finally, we'll have recessive for both traits. So if we are to count our offspring here, how many are dominant for both traits? We're looking for a capital B and a capital E. There are 9 of them. For our second combination, dominant for the first, recessive for the second, there are only 3. So we're looking for, write it down here, we're looking for the dominant but 2 recessives. For our third one, it's also 3. We're looking for recessive but dominant for the second. And then finally, we're looking for recessive across the board. There's only 1. So our phenotypic ratio is 9 to 3 to 3 to 1. For dihybrid crosses, we typically do not perform genotypic ratios because they are very complicated. You should check out the following pages and see if you can do some of the Punnett squares on your own. Pick a few of them, give them a try, and I'll post the answer key for you to check. If you have any questions, please do send me an email, and we'll make sure that you can get your questions answered. We'll also be having a quiz at the end of the week on genetics.